In this video, I will try to explain non-uniform circular motion. Circular motion can be uniform or non-uniform circular motion. And the non-uniform motion is the rate of rotation keeps changing through a circular path. So it means that the body moves in a circular path, but with a variety in velocity. Not just in direction as uniform circular motion, but it is also in the magnitude of the velocity. So in this case, we have two acceleration and two forces. As we have radial component of acceleration, which is centripetal acceleration, there is also tangential acceleration. So also the force acting on the particle have tangential and radial component, which is centripetal component, because the total acceleration is equal AC plus AT, which is centripetal acceleration plus tangential acceleration, give us the summation of acceleration acting on the particle or on the body. And also the summation of force, it will be summation of force in radical component or in centripetal component plus summation of force acting on the tangential component. And this figure explained how the body moves in a circular path and to change its direction and its magnitude. And as an example of that, if there is a car moving in a circular path, but it changes its velocity, as at first it starts to move in the circular path with 5 meters per second. In the circular path, after 3 seconds, it changes the velocity and it becomes 7 meters per second, and also change its direction. So we also have a centripetal acceleration. But the difference between it and the uniform acceleration is that there is also tangential acceleration and tangential force. And that non-uniform circular motion, its rotation keeps changing as direction of velocity and the magnitude of velocity. In this problem, we have that body moves with mass 2 kg and with tangential acceleration equal 5 meters per second square, with radius 3 cm and velocity 9 meters per second. Calculate the net force acting on the body. At first, to calculate the net force acting on the body, we should calculate centripetal force and the tangential force. And as we have V, which is velocity, and R, which is radius, we can calculate the centripetal acceleration. To calculate the centripetal force, which is m times centripetal acceleration, we should at first calculate the centripetal acceleration, which is v squared divided by r. So we can calculate it by squared the 9 and divided it by 3. Then we have the centripetal acceleration, which is 27. Then we will multiply it with the mass to give centripetal force. So we have centripetal force with magnitude 54 Newton. Then we will calculate the tangential force, which is mass times the tangential acceleration. And we have directly tangential acceleration in the problem, which is 5 meters per second square. And we have the mass with 2 kg. So we multiply 2 times 5 to get 10 Newton, which is the tangential force. Then to get the net force, we will add the force, centripetal force, to the tangential force, which will give us 10 plus 54, which is 64 Newton. In this video, I tried to explain non-uniform circular motion and its difference from uniform circular motion and with given problem. Thanks.